Welcome everyone to this section on modules and packages. In this lecture, we're going to start off by talking about PyPy with pip install. PyPy is a repository for open source third-party Python packages. And if you've worked with other programming languages, it's similar to RubyGems in the Ruby world, PHP's packages, CPM for Perl, and NPM for Node.js. So far, we've really only used libraries that come internally with Python, and these are known as the standard library or the built-in libraries for Python, things like the math library. Now there are many other libraries available that people have open sourced and shared on PyPy, and these are also called packages. And we can use pip install at the command line to install these external packages. By installing Python from python.org, or by installing the Anaconda distribution, as shown earlier in this course, you actually have already installed pip. And pip is a simple way to download packages at your command line directly from the PyPy repository. Now there are packages already created for almost any use case you can think of. Python is a hugely popular language and it's growing very quickly. So that means if you ever want to work with Python with some other external use case, maybe you want to make web development with Python. So you would Google around and eventually discover that there's libraries such as Django or Flask for web development with Python. Or maybe you have a more specific use case like working with PDFs with Python or working with Excel documentation with Python. In that case, you can always do a quick Google search, and almost always the links that come up first are either the PyPy page for the package or the package documentation. And we'll show you a little exercise of what a good Google search looks like. So what we're going to quickly do now is show you how to download and install external packages. To do this, we'll open up our browser, but we're also going to be working at our command line. So remember, for Windows users, that means open up your command prompt, and for macOS and Linux users, that means open up your terminal. So let's have a browser open along with our command prompt. Okay, so here I am at my command line, and let's show you how to install a package that's hosted on PyPy. Something you do need to be aware of is that your firewall may block pip from accessing the internet. So if you're on a work network or you're on a work computer that you don't have full admin permissions, you may need to check that or talk to your network administrator. But let's move on, and what we're going to do here is type pip install space, and then here's where you would actually put in your package name. So there are a ton of packages out there. We're going to start with a package that you may already have installed because you've installed Anaconda, and that's the request package, which allows you to request information from websites online. So this is just a general syntax of how you would download a package. Notice here, I'm typing this directly into the command line or directly onto my terminal or command prompt. I'm not actually calling Python first. This is a command line utility. So you hit enter here, and you may get the requirement already satisfied. Most likely, if you installed Anaconda, you already have requests installed. So this is what it looks like when you already have it. What I'm going to show you now is a library that you most likely do not have yet, and that's the Colorama library. And this is just a bit of a silly library that allows you to print out colorized text at your command prompt or at your terminal. So type pip install Colorama, notice the spelling here, hit enter, and we actually already have it installed because I ran this line already. So what we're going to do now is run the actual Colorama external package that we just installed. So what I'm going to do now is type Python, and let's try checking out Colorama. So to do this, it's actually quite simple. All you need to do is say from Colorama import init, and then on the next line, call init. So basically is a bit of an initialization function that allows you to set up depending on what platform you're using. And then what we can do is say from Colorama import, and what we're going to do here is say import for, so that's capital F-O-R-E, which stands for foreground. And then I will create a print statement that says for dot, and then in all caps red, plus, and I will just say some red text, and then hit enter. And now you see I have red text. And we can do that with a variety of colors. So I can say now print for green plus switch to green. And now we've switched to green. So again, just a very simple library that allows you to incorporate color directly at your command line. This is not a library we will ever really be using again, but it's just something fun that you can play with. And you can check out the documentation simply by Google searching Colorama. What I want to show you now, let me quit out of this Python session, is show you how you would actually create a Google search and what kind of things to expect to pop up when you're looking for an external package that you may not know ahead of time. So for example, let's try to solve the problem of trying to work with Excel files in Python and figuring out a package that allows us to do that. So when you're looking for a Python package for any particular workflow, it's always best to start with just a simple Google search. And I know hopefully this seems pretty obvious, but a lot of times the best thing to do, and pretty much everybody does this, no matter how experienced a developer they are, is you just Google search Python package for, and then whatever they're looking for, whether it's Excel, for PDFs, and you should always end up seeing in the top results some sort of link to helpful information. So let's start off with the example for Excel. And as we scroll down, we'll eventually see python-excel.org. And if you click on that link, it actually reports back a bunch of packages that are available. OpenPyXL, XLRD, XUtils, a ton of stuff that you can play around with. So then what you end up doing is you either go to the documentation or you go straight to the download link. And typically when you go to the download link, it takes you to the Python Software Foundation website for PyPy, so pypi.python.org. And here's just official information about the actual package. Depending on how big the package is, if it has more users, it almost always has a separate documentation page, and the documentation will be linked somewhere in the top few lines. So you click here on package documentation, and it will take you to the official documentation for that actual package. And a lot of times they're hosted by readthedocs.io. So now here we see some nice documentation, and what we can do is figure out how to install it from this documentation, or typically what you end up realizing is it's always just pip install and then the name of the actual package. So we know that it's OpenPyXL. Let's now go back to our command line and install it. So then here, back our command line, what we're going to do is say pip install OpenPyXL, hit enter, and I've actually already run this before, but that's how you would install a package from the internet from PyPy. And then later on, you could call Python, and then you should be able to import OpenPyXL with no issues. That's the basics of using pip install with Python and figuring out what external packages are a good fit for you. Hope that was useful. If you have any questions, feel free to post to the Q&A forums. Coming up next, we're going to learn how to create our own modules and packages using Python. We'll see you there. Welcome back, everyone. In this lecture, we're now finally going to discuss how to write your own modules and packages. So we understand how to install external packages that people uploaded to PyPy. Let's explore how to create our own modules and packages. And to clarify some of the semantics here, modules, it's really just a .py script. So it's a fancy way of saying, here's a .py script that I'm using in another .py script. So that act of using it in another .py script allows you to call it a module. Again, this is really just semantics, but packages are then a collection of modules. However, there's a key .py script called __init__.py that needs to be placed inside of a folder to let Python know that this collection of .py scripts should be treated as an entire package. So we're going to show all of this through some examples. Keep in mind, since we're dealing with .py scripts here, we're not going to be able to show these examples through the notebook. Instead, what we're going to need to do is use Sublime Text Editor or any other IDE that works with .py files in order to create the scripts and folders. Let's get started by opening up Sublime Text Editor. Alright, so we're going to start off by creating two files here. The first one, we'll save it to the desktop. We'll say File, New File, or we can actually save the one we currently have. Save as, and on my desktop, I'm going to save this as my module.py. So this is the module, and remember all that a module is just a .py script being called in from another file. So let's create that other file. We'll say new file, and this one, we're going to save it also on the desktop in the same location as my module.py, and we'll say my program.py and save that. So inside my module, what I'm going to do is just create a very simple function. We'll say def, and then say myfunc. And all this does is it prints out, hey, I am in my module.py. Control S to save that. And then in my program, this is another .py script, and I want to use the code from my module. So here we can get the idea that if you have a really large script, you're not going to put everything in one giant .py file. Instead, it will be nice to split it up between multiple .py files, which means just split it up between different modules. And then later we'll see how we can aggregate a bunch of modules to create a package. So far, what we're going to do is in my program say from my module import, and then we're going to import my func. And let me make sure I spell that right. Okay, my_func. And that means I can now call it here. So we'll say my_func. I'm going to save this, and let's see if it worked by going to our command line. So here I am now at my command line. Remember, I saved these files at my desktop. So let's cd to the desktop, change directory. And now I should be able to call Python, and then call my program.py, hit enter, and I see, hey, I am my module.py. So we were able to successfully call the other function from the other module.py file into my program.py. And this is the very basic way of how you would actually format .py scripts in order to not have everything in a single script. Now at a certain point, even this is going to start to be too much, and now you're going to want to aggregate modules together to form a package, and that way you can have different folders for different packages. So let's now show you how to create a packages. So we're going to come back here to my program.py and my module.py, and we'll open up and say new file, and then we're going to save this, save as, and here at my desktop I'm going to do a few things. The first thing I'm going to do is create a new folder here. And this folder, we'll call it my main package. Hit enter. And then inside of this folder, we're going to create another new folder, and we'll call this sub package. So we're going to be creating lots of files and folders here. So right now we have at my desktop my module.py and my program.py, and I've also created my main package folder, and inside of that I have my sub package. Now, since these are just directories or folders, we need to let Python be able to understand that we want to treat these directories not just as a normal directory, but as an actual package. So to do that, inside both my main package and sub package, I'm going to have to create a file called __ init, init, __ .py. Save that, and make sure you have this init py file in your package. Now, you don't actually need to write anything in this file. It just needs to be there so that when Python goes searching through these packages, it understands that it's not just a normal directory, it's an actual package. So we're going to create one more file. We'll say new file, and we're going to save this. Under sub package, we'll create another __ init __ .py file. And again, this one's going to be blank as well. So we have both of these. Notice here how Sublime's telling us which one we're referring to, this one in main package and this one in the sub package. So we're going to close these. We're not going to be working with them anymore. We just need to have them named there. Okay, so I have my module and my program. What I'm going to do now is say file, new file, and I will say save as, and inside of my main package, and I'm going to create some main script.py, save that, and then what I'll also do is say file, new file, and let's put another .py script inside of my sub package. So we will say file, save as, and inside of this sub package, along with that other init file, we're going to create the following. We will say my subscript.py. So now I have this outside module, some main script inside of that main package folder, this subscript inside of that sub package folder, and then my main program. So what we can do is we can start playing around with this all the way from my program. So what I'm going to do is inside of my subscript, we'll say def, then say sub report, and have that print out, hey, I'm a function inside my subscript. Control S to save that. we're going to do a very similar thing here in some main script, and we'll say def. We'll call this report main. And this will print out, hey, I am in some main script in main package. Save that as well. Okay, so let's take a look at the directory right now. We'll say open file just so we can explore this. So at my desktop right now, I have this mymodule.py. I won't really be playing with that anymore, but instead I have this myprogram.py. And we can think of myprogram.py as the main.py script I want to run. And I want to organize my files into packages. So right now we've explored how to actually create a single module, which is just a .py script. And you can imagine we'd be importing from various modules, so various .py scripts, but at a certain point it's going to be too much and we want to organize them into folders. So the way you would do that is you would have packages, which are just directories that have this init.py, so __init__.py, and that tells Python, hey, this actual directory, it has a bunch of modules in it, so you can call them using a certain syntax, which we're about to show you. So here we have some main script. You can imagine I could have many more .py scripts or many more .modules inside of this main package, and we can keep going with sub packages as long as they have this init.py, and here I can see my subscript. So I'm going to cancel this, and what I'm going to do is inside my program.py, I've already know how to import from a module, but now let's realize how to import from a package. To import from a package, what I can say is from my main package, I can either import the actual module itself. So remember the module in my main package, it was called some main script. So we'll say some main script. And if I wanted to import from a sub package, what I would do is say from my main package dot sub package, and then I can import some module from there. So in this case, it was called my subscript. So this is now how you can organize not just into a single directory, but you can actually organize into subdirectories as well. And this is the syntax for that. You say dot, the name of that sub package, import, and then import the modules. And if you want, you can go even further and actually import only specific functions. So we'll show you how to do that in just a second, but let's actually call the functions from some main script. So from some main script right here, we want to call the function that's inside that script. So if we click back here, we realize that that one is just called report main. So coming back, we'll say some main script, report main, close parentheses. So we're actually executing the function report main, which is under some main script module, which is under my main package. Then we also want to, if we look at my subscript, that has the sub report. So let's run that as well. We'll say my subscript, call sub report, open close parentheses. So let's save that, and then let's run my program.py at the command line so we can see what happens. All right, so now here I'm back on my desktop at the command line, I will say Python, call my program.py, and I hit enter, and now I see, hey, I am some main script in main package, and then, hey, I'm a function inside my subscript. And that's it. Now you've successfully not only created a module in the first part of this lecture, but you've also created packages and sub-packages. And in general, the idea here is just how do you organize various Py scripts? As you begin to grow better and better in Python, you're going to write more and more Python code. So at the beginning, you'll create a couple of modules. They'll all be in the same folder, no big deal. Then, as it starts getting more and more unwieldy to have it all in the same folder, all you need to do is create directories that have that special __init__.py file. That just tells Python, hey, this is now a package, and it allows you to run what we see here, this my main package, my main.sub package. Okay, that's the basic idea of packages and modules. If you have any questions, feel free to post to the Q&A forums, and we'll be happy to help you out there. I'll see you at the next lecture. To finish off this section of the course, I want to discuss these two ideas of name and then the string main. So an often confusing part of Python is when you start looking at larger .py scripts that you haven't written yourself, you often see at the very bottom this mysterious line of code that says if __name___ is equal to the string underscore underscore main underscore underscore colon, and then there's a block of code to be executed. So sometimes the whole idea behind that line of code is that when you're importing from a module, you would actually like to know whether a module's function is being used as an import or if you're using the original.py file of that module. So what we're going to do is explore all of this a little bit more, but make sure to check the full explanatory text file that has a written explanation of everything we're going to cover here. What we're going to do basically is just create two simple .py scripts and try to show you the idea behind that if name is equal to main block of code that is usually at the end of larger .py script files. Let's get started. Okay, let's begin by actually creating two new files. We'll create them at my desktop. I will say for this first file, save as, and I'm going to save this as 1.py. So this one is 1.py. Then I will create a new file, and I'm going to save this one as 2.py. 2.py, again at my desktop, so we'll label this one 2.py. So make sure you have those saved. So let's think about what actually happens when you call a Python script at your command line. You go to your command line and you type Python space the name of your script .py. So what's actually happening when you call Python myscript.py, all of the code that's at indentation level 0, essentially something like this, is going to get run. So that means any code that's at indentation level 0 is going to get run, and that would mean that your functions, which are automatically usually going to be defined at indentation level 0, and your classes, also at indentation level 0, are all going to be defined. So unlike other languages, in Python, there's no main function that you call somewhere at the top of your script that gets run automatically. Instead, what happens is, just implicitly, all the code at this indentation level 0 gets run when you call the script file. And you probably have an intuition of that by now, since we've been working through that strategy the entire first half of the course. Now, in Python, there is actually a built-in variable called name. So just like there's built-in functions, this is a built-in variable. And it's quite obvious that it's built in because we have two sets of double underscores in the beginning and in the back of it. So that would allow you to have to really try to overwrite it by accident. So what happens is this variable name gets assigned a string depending on how you're running the actual script. And if you run the script directly, so if I went to the command line and I wrote out Python space 1.py, what Python is going to do, it's going to assign this built-in variable called name to be equal to underscore underscore main. So Python does this in the background. Well, it really does this. It assigns this string to the name variable when you run it directly. And that allows you to have an if block to check if they're equal to each other. So often what you do is something like this. You say if name is equal to main, and then you can do something because you know that this particular .py file is being run directly. And if you ever run something directly of Python, you know this case happens to be true. So what happens is often people will just, at the very bottom of their code, they'll say if name is equal to main, and then they say kind of run a bunch of functions that they defined here. So at top, they do a bunch of function definitions. So function number 1, function number 2, so on and so on. So you can imagine hundreds of lines of function definitions or classes. And then all the way at the bottom, they actually organize their code on what they actually want to execute. And they know that they want to execute it because they say, if this built-in variable called name happens to be equal to the string main, then I know I'm running this .py file directly. So we're going to explore this whole idea a little further. And to do that, we're going to do the following. In 1.py, so let's go back here. This is 1.py. I will write out the following code. I will say def, create a function, and this function is going to be very simple. It will say func in 1.py. So when you call that function, it says func in 1.py. It's just printing that out. And then what I'm also going to do here is at an indentation level of 0, so outside of this function, I will say top level in 1.py. So now I have a function definition as well as a global print statement top level in 1.py. Then at the bottom of this, I will say if, and you'll notice that Sublime Text Editor will actually autocomplete this for you. If name is equal to main, I'm going to delete this. So I have an if block of code here. So if name is equal to main, then I know I'm running this directly. So I will say 1.py is being run directly. And then I'm actually going to line up an else block with this if statement. You don't see this that often. You usually just see if and then you execute all your code. But just to make it clear how this variable is working, we'll also add in an else there. We'll say else print 1.py has been imported. So I'm going to save that, and let's take a look at what happens. I define this function, I print out this statement whenever you call 1.py, and then depending if 1.py is the main script, meaning I'm calling 1.py directly at the command line, I will print this out. Else, that means the variable name was not set to main, and I will print this out. 1.py has been imported. So now let's work with our second file, 2.py. What we'll do here is say import 1, and I will print out at the very top level. Let's print out something like top level in 2.py. And since I just imported 1, let's execute the function that's from 1. We'll say 1.func. And here we're going to have an if statement. We'll autocomplete this. If name is equal to main, I will print 2.py is being run directly. Else print 2.py has been imported. So let's save the changes in both of these and then open up our command line. Alright, so the first thing we're going to do at our command line is actually run 1.py directly. So we run this and we notice what happens. We get that print statement, top level in 1.py, and then we see from that if name is equal to main, 1.py is being run directly. So we can see here that that built-in variable __name __ has been assigned that main string. So Python then knows, and the entire script can know, that 1.py has been called directly. But now let's check out Python 2.py. So now when I run this, notice what happens. I get back top level in 1.py, but now 1.py, its built-in variable of name has not been set to main because it's been imported. So now we get back 1.py has been imported. And then I get top level in 2.py, func in 1.py, and then 2.py is being run directly. So that built-in variable actually allows you to see whether something is being imported or run directly. So that's the idea and concept behind the variable name, and checking if it's equal to main. Typically, however, what you see is people, they don't really do it the way we've done here where they check is something being run directly or not. Instead, if we come back to Sublime Text Editor, what they do is instead of having an else statement here, since they just say if name is equal to main, this is the same thing as saying run the script, right? Because we already know that if this happens to be the case, then someone is running 1.py script directly. So what they do is they define a bunch of functions up here or define their classes. So here's another function, pass. You write some other function, function2, save, and then down here at the bottom, what you end up doing is you just call your functions. So you'll say, okay, execute function2, then execute function1, and then maybe you have a little bit of logic here. But the main idea is that this is more for code organization. You have all your functions and classes defined up here, and then your logic, where you actually execute things, are defined here at the bottom. And this is a really common structure you will see for larger .py scripts, especially when you begin to use modules and packages. Alright, that's the basics of this line, if name is equal to main. Definitely check out the explanation.txt file that goes along with this lecture, and if you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture.